Hello, everybody, and welcome back. This is Big Time Math, and today we're talking about A3C, graphing linear functions on a coordinate plane. All right, we're going to talk about using the intercepts to actually graph any linear equation, and I have three examples for you, so let's go ahead and get to it. So let's check out example one. Example one, we have in standard form, it says 2x plus y equals 4. The reason why I say standard form is because in 8th grade, we learned how to graph mx plus b. Well, what if it's not in that form with the slope and the y-intercept? We need to find a way to graph this. So today I'm going to show you how to use the intercepts. Now remember, if I'm looking for the x-intercept has an x value and a y is 0. And if I'm looking for the y-intercept, I have a 0 for the x value and I have a y value. So as long as we can plug in 0 for the one variable, we can find the actual missing intercepts. So we're going to start off with trying to find the x-intercept. So if I'm looking for the x-intercept, then my y value is actually going to be 0. So let's check that out. So if I have 2x plus, and instead of y, I put in 0. What you notice is I'm left with one variable, and it's the x variable. And when I solve for x, I will have the x-intercept. And so this is pretty simple because this actually cancels out there. So I'm left with 2x equals 4. Then in order to get x by itself, I simply divide by 2. And so in this case, the x equals 2. So my x-intercept is 2. And if you wanted to, you could label that point 2, 0. And you see how I have an x value and my y value is 0, my x value is 2. So we have our x-intercept as 2. But let's find the y-intercept. And so in this case, if I'm finding the y-intercept, remember the x will be 0. So I'm going to redo this problem with plugging in 0 for x. In this case, it says plus y equals 4. And what's really nice about this problem here is that the x's cancel out. So I'm left with just y equals 4 because there's no coefficient in front of y. So y equals 4. So I can just rewrite that as y equals 4. So I'll go to the y-axis, and there's my y-intercept. And if I want to rewrite that point, I could say 0, 4. Now that I have my 2 points, we only need 2 points to graph a linear function. So I'm going to do my trusty line tool. And as it loads, it looks like we already see that that is going to be negative slope. So I'm connecting one point to the other, and I can extend this about. And bam! Look what we have right there, folks. We do have our linear function graphed on this coordinate plane using two key features, which were the intercepts, the x-intercept and the y-intercept. So as long as you plug in 0 for one variable, you will find the x and y-intercept for the others. All right, let's give an example 2 a shot. Same work here. If I'm going to find the x, then I'm going to plug in 0 for the y. So we're going to start off here. Need the pen there. How about 3x minus 6 times 0 equals 12. And 6 times 0 is 0, so that goes away. So I'm left with 3x equals 12. And we can simply see that when we divide both sides by 3, that the x-intercept in this case will be 4. So I'm going over to the x-axis, and there's my x-intercept. We're going to do the same thing for the y value. So we're going to say, instead of x, we're going to need a 0 for the x. Minus 6y equals 12. I can come over here. We see that this cancels there. So negative 6y equals 12. And if you'd like to rewrite this to make it cleaner, you definitely can. So divide both sides by negative 6, and in this case, y equals negative 2. So there's my y-intercept, negative 2. Now again, if you want to rewrite these as ordered pairs, you definitely can. So since it's the y-intercept, we know it's 0, negative 2. And then we can come back up here to the x, and we wanted to rewrite this as 4, 0. And we'll look for our trusty tool here to connect the dots. And we have used the intercepts to graph this linear function, even though the function was not in y equals mx plus b or slope-intercept form. Now, if you want to check out that work again, you definitely can pause this video and go back and check it out. But let's try one more quick one, but let's do it in our head, right? So what if I want you to find the intercepts, but we're not going to graph? And so what could I do? Well, if I'm looking for the x, technically couldn't I do this? Get rid of the y? Because if I'm plugging in 0, the y is going to go away. And then I have 4x equals 24. And if we remember, oh, if I divide both sides by 4, then 24 divided by 4 means the x-intercept is 6. Oh, wow. We just did that in our head. Now, what if I take this and move it over here to cover up the x? Now I have the y. And then 24 divided by -3 is, let's do y equals -8. And there I have it, my x-intercept and my y-intercept. And so I could go, if I was going to graph it, I'd go over here to 6, and I would go down here to -8, connect the dots, and I would graph my line. But I don't need to do that because I can use mental math to find the x and y intercepts when the equation is in standard form. All right, I hope you like this video. Remember, you can rewind and check it out if you'd like. This is Big Time Math in A3C, graphing on the coordinate plane. Peace out.